Hi there. I'm here to explain to you what physics is and what you may expect to do if you select this subject as one of your senior subjects. Physics is the study of matter and energy. It is the oldest of all the branches of science and is considered to be, by many, to be the most fundamental of the sciences. As such, without an understanding of physics, we cannot understand chemistry or biology. It has been a focus of systematic study for thousands of years by some of the biggest names in science, including Aristotle, Galileo, Newton, Einstein, and Hawking, and a lot you've not heard of. You may not realise it, but physics is around us every day. The motion of cars and aeroplanes and electricity in your home, and even the way your blanket works, are all studied by physicists. They observe the natural phenomena around us and they try to determine the rules the universe obeys. These rules are called laws, and these laws form the foundation of all science. You may be familiar with some already. In fact, Isaac Newton features prominently in senior physics and is best known for his 3 laws of motion, his law of gravity, and even his development of calculus. Which brings us to the next point. Physics is the most mathematical of all the sciences, and students who do well in physics need to have very good mathematical skills. If you find the idea of solving problems using equations and calculations interesting, then physics may just be your cup of tea. The physics course has 8 units that are studied, and I'll explain each in turn. The units are called, in Year 11, kinematics, dynamics, waves and thermodynamics, electricity and magnetism. And in Year 12, advanced mechanics, electromagnetism, the nature of light, from the universe to the atom. Let's look briefly at each unit in turn to gain a better understanding of what each entails. Kinematics is the study of motion in 1 and 2 dimensions. We look at objects as they move at a constant velocity and as they accelerate. We also look at vectors and scalars and how vectors can be used to represent motion in 2 dimensions. In dynamics, we extend on kinematics by introducing mass into the mix and learn how objects behave in complex situations like roller coasters, and also what happens in collisions between objects. Waves and thermodynamics takes us into the world of how waves behave and how these rules can be used to explain anything from radio reception to how a trombone works. We also delve into the idea of heat as energy and how this form of energy flows from one region to another. Electricity and magnetism allows us to look at simple and complex electrical circuits and how we transmit electricity over long distances. We also investigate how magnetic fields form and their relationship with electricity. As we start in Year 12, we then move on to more complex phenomena. Advanced mechanics takes what we learn in kinematics and dynamics and applies them to projectile and circular motion. We look at the flight path of a projectile launched through the air and build models to predict its motion. We apply our understanding of these concepts to also investigate and explain the movement of planets around our sun. Whilst we're extending our understanding of Year 11 units, we also extend our understanding of electricity and magnetism to look at the phenomenon of electromagnetism. Here we investigate the behaviour of charged particles and their interactions with electric and magnetic fields, and how we can utilise these interactions to build induction devices like transformers and cooktops, as well as electric motors. Then, whilst we're still looking at electromagnetism, we will explore the nature of light and how light has been considered for thousands of years. We look at the problems with this idea and how an explanation of light led to the creation of modern physics by way of both quantum theory and special relativity. These advanced concepts, whilst not very mathematical, use logic to arrive at some very illogical conclusions that defy common sense. In our last unit, we look at the very nature of matter itself. In From the Universe to the Atom, we explore the atom and how we've come to know what we do about it. We discover the behaviour of subatomic particles and revisit the laws of quantum theory and their ramifications for the atom. We end with looking at nuclear radiation, its cause and uses, and further investigate the latest theories about what is really happening in the subatomic world. The new HSC physics syllabus also provides students with the opportunity to take a concept they find interesting and conduct depth studies in Year 11 and in Year 12 to demonstrate their understanding of these concepts. Students will have the choice of how they would like to extend their knowledge and present their information. In fact, it allows students to play to their strengths and show off what are their capabilities. People who have studied physics can find themselves working in such varied careers as pilots, engineers, scientists, medical sciences, in the Defence Force, and even mining. For those students who demonstrate a high aptitude for physics, they'll have the option of selecting Extension Science in Year 12 to further their understanding in a senior research project.